question now that has to do with chemistry. Let's see. Let's see this. So, um, Mercy, check this question. Is she there?
Yes.
Yes, I'm here.
Read the question, let me hear, then try to pick your answer.
Equal masses of calcium tribicarbonate 5 were added to dilute hydrochloric acid at the temperature specified. Which of the following conditions is the reaction lowest? Let's see.
So, try to check the options and pick your option.
Patient was four chips at 20. Patient was four chips at 40. Patient was chips.
So, which one do you go for?
I'm thinking, so I don't know, I'm not sure. But I don't know whether it's chips or powder. So maybe I'll go for D.
D, right?
Mm,
What they are trying to test here, are you all listening?
Yes, sir.
What they are trying to test here is whether you know factors that affect the rate of reaction. Okay? When you increase the surface area of a reactant, then the rate of collision or frequency of collision increases. Therefore, that will increase the rate of reaction. So, the powder at 40 will be faster than the chips at 40. You know, chip is like solid, okay? More solid than powder. Is that clear? Then the powder at 20 will still be faster than the chips at 20. So which one now do you think will be the slowest?
I was chips at 40.
Wait, chips at 40, right?
Mm,
You say under the same condition. Do you know that 40 degrees is higher than 20 degrees? So try again.
okay, at 20.
Yeah. So option A, right?
Yo.
Okay, that's good. So the next question, let's see this one for Moses. So Moses, read the question. Let me hear you.
The high solubility of ethanol in water is due to A. Its low boiling point, B. Its low freezing point, C. Its covalent nature, D. Hydrogen bonding.
So what do you think should be um, the answer? You're talking about ethanol that it has high solubility in water. What does that mean that it has high solubility in water? It means it can dissolve in water, okay? It will mix with water and you might not even see the traces. Exactly.
Yes.
You will still see it, but unlike when you pour something of low solubility in water. Exactly.
You.
So now, which option do you think makes ethanol more soluble in water?
See,
Okay, covalent nature. It has something to do with bonding, but not covalent, but hydrogen bonding. Okay, so ethanol is an alcohol that is soluble in water, and this is because of ethanol has hydroxy group, which is the OH minus in the ethanol, and it is able to form hydrogen bonds with the water molecule H2O. So,
Sir,
yeah,
so I think that they will say that. So hydrogen bond now. So specific hydrogen bond can dissolve the water.
you said
Hydrogen bond like chlorine can dissolve the water.
hydrogen bond like chlorine. No, what chlorine?
Example of hydrogen bond is chlorine.
No.
Yeah, that's what they give us now.
Oh,
Chlorine.
wait. Hold on. I think we should. Hold on. Now, listen carefully to this. Molecules that contain a hydrogen atom and bound, it can bound with fluorine, oxygen, or nitrogen are considered examples that show the hydrogen bonding process. So, water, ammonia, hydrogen fluoride are examples of hydrogen bonding. What chlorine possess is electrovalent bonding because of its high electronegativity. Okay, so
So this ammonia is under hydrogen bond.
yeah, ammonia possess hydrogen bonding, and that doesn't mean that is the only nature ammonia has. Is that clear?
Yes.
So the next question is Sarah there.
yes, sir.
Okay,
Yes.
let's see the question for Sarah. Is Taye around?
Yes,
Yes,
sir.
sir.
Okay, so after Sarah will be Taye. So Sarah, please read this question and let me hear. Read it out. Let me hear.
The following pairs of properties of alkaline metals decrease decreases down the group. A. First ionization energy and reactivity. B. Melting point and atomic radius. C. Reactivity and electronegativity. D. First ionization energy and melting point. So the answer is D.
First ionization energy and the melting point, right?
That's right.
Right? Yeah, I'm only asking. I mean, are you sure of your answer? The answer is correct, but I'm only asking whether you are sure of what you have picked. The ionization energy of an atom is the amount of energy that is required to remove an electron from a mole of its atoms in the gas phase. So it is possible to remove more electrons from most elements So this quantity is more precisely known as
Stop
first
you.
ionization energy. The energy to go from neutral atom to the cations with a plus one charge. That is the first ionization energy. And we're saying it decreases, the ionization energy decreases from top to bottom in groups. Why should ionization energy decrease from top to bottom in group? Who can explain that? Anybody?
Stop you. Repeat what you said.
Why should, we said ionization energy will decrease down the group, right?
Yes.
So why should ionization energy decrease down the group?
Why should the understand make the figure
And
go?
what is the explanation behind that? And why will it decrease down the group? Why will it increase from right to left? Does it have anything to do with the number of electrons in the outermost shell? Okay,
Sorry.
let's consider hydrogen. Hydrogen is not a metal, but it's in the reactivity series. Okay, let's go down to metal in group one.
Mm,
Let's consider sodium. Sodium has one
yes.
electron in the outermost shell, right?
Yeah.
So if sodium has a certain ionization energy, first ionization energy. So what do we say of any element that will be under sodium down the group? For example,
Okay.
under sodium we have potassium, right?
Yes.
So potassium has also one outside the. So what is different between potassium and sodium will be the number of shells. Okay.
Yes.
So for example, sodium we have 281, which is three shells, and calcium we have calcium is 19. That would be 2881, right? So we are saying sodium require higher ionization energy than
Calcium.
potassium. So it might have to do with because that is the obvious change between them. The number of shells changes. Okay, let the next question be for Tai. Let's see. So Tai, read this.
The most. How is it back? Okay, the most general of obtaining water from aqueous solution of sugar is fertilization.
You said, which one did you call it? Is it A? Which option did you go for? Which option do you go for?
Hello, sir.
Yes, I can hear you now. Which option did you pick?
Yes, sir.
A. Okay.
Yes,
You
sir.
said crystallization.
Yes.
Crystallization is primarily used as a separation technique to obtain pure crystals of a substance from an impure crystal. Pure crystal of a substance. Here, this time around, another important application of that crystallization is that it is used to obtain pure salt from seawater. Simple syrup crystallizes when enough of the sugar molecules stick to one another that they become insoluble in water. So the process of obtaining water is distillation. Okay? Distillation is used to obtain a solvent from a solution. So the correct option is B. Okay? If it
So
is the
how is the distillation? Oh,
listen again, that's what I just explained. Listen again. I said if it is the crystals, pure form of the crystal you're looking for, use crystallization. But if it is pure form of a solvent that doesn't contain anything else, use distillation. So distillation is used in obtaining pure form of solvent from a solution. Okay, is that clear?
Yes, sir.
no.
Yeah. Okay. What is distillation? That the person that said it's not clear. What's distillation?
So I don't know, but what they taught is from what I was taught in school was crystallization for sugar and salt. So
If you want to,
what I was taught in school.
did you read the question?
Important.
What are you trying to
Yes,
obtain?
now because apply sugar from sort of sugar solution. If
Wait,
you move the sugar,
wait. Is it
water.
sugar you are trying to obtain from here or water? Check again.
Removing water now, taking water from
Uh-huh.
aquarium
So is it the water that the emphasis is on or the sugar?
water now.
So you said crystallization is for obtaining the water and sugar and salt, right?
Yes,
Yeah,
sir.
that's
Which
what it
is
says in
hello,
school.
which is correct. But if the emphasis is on the solvent, it is distillation. Okay? Are you getting that?
Yes, sir.
Uh-huh. So if the emphasis is on the solvent, use distillation. If the emphasis is on the crystal being in the purest form, use crystallization. Is that clear? Is that clear now? Distillation process involve the conversion of a liquid into vapor, which is subsequently condensed back to liquid form. Okay? When you put when you grind your pepper and onion and everything and you put them in pot as soup and you boil it, when it is boiling, some vapor stick to the cover, yes or no? Some
Yes.
hot vapor stick to, and when you open it, what kind of water comes out, pure or impure?
Here.
That is it. From the red oil, from the pepper, from the from all of those stuffs, that process is synonymous to the process of distillation. Is that clear?
Yes.
Okay. So the next question goes to Messi, right?
Yes.
Okay. So what's the name for okay, that's the let's see. So look at the next question. Read this, Messi.
With several elements in their combined state. With several elements, with several elements in their combined states are called.
Are called dash.
Okay, right, you were meant to say the answer.
What's the answer?
Good, you take good seven.
Group
Because I
7,
know
group 7,
some.
group 7.
Oh, good seven counts. The allergens.
It's true that they are halogen, but if I give you the options, like, let me see.
They are not. They are not. No, don't listen like this. People they cannot see. Don't listen like this. You don't have to see.
Now, look at the options. Halogen is there, right?
Yes.
But did you read the question properly? It said in their combined state. In their what?
We are converted then to be allied.
Halide.
Regularly. Allied.
Halide.
Allied,
Halide.
yes.
So take note of that. If it's an exam and you pick halogen without reading the question, that's a no going back, okay?
Yes, sir.
So let's see. The next one is for Moses. Yeah.
Yes.
So Moses, read this out and let me see your answer. Yes. Read it out. Let me hear.
When an ionic bond is broken, bonding electrons are shared between participating atoms, gained by the most electro, electropositive atom, lost by gained by the most electronegative atom, lost by both participating atoms.
So what is the answer? Which answer do you go for?
The- Lost by both participating atoms.
Atom. Okay. When when electron is, oh wait, that can never be in a chemical reaction.
D,
D, D can never be. Okay. No.
So to begin by those electrons,
By what?
most electronegative
C, right?
activity. Yes. Come on, chicken.
Yeah, the correct option should be C. You know why it cannot be this D? If one is losing electron, the other should be gaining it, or they should be sharing it, okay? So the electron will not be totally lost in a reaction. Is that clear?
Yes, sir.
Then why must it be gained by most electronegative? Yeah, let's take hydrogen and chlorine, for example. Hydrogen is going to lose the electron to chlorine, though they are still going to be in a combined state. But if we look at another example like sodium chloride, so sodium is 281 plus chlorine, which is 287. When they combine to form this, The sodium present in this will be 2,8, 2,8. While the chlorine
Yeah.
present in this will be 288.
It is.
So,
Seven.
and chlorine is the most electronegative, okay?
Yes, sir.
So it's the one that gained the lost electron. Is that clear?
Yes, sir.
And I think that's where we'll be switching over to physics. Hold on a bit. So given that V equal to U plus AT,
Yes, question.
explain.
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 Yeah,
Wow.
explain how V equal to U plus AT.
Yeah, look my physics now.
Yeah, I'm giving something. I'm giving something. Yeah. I'm giving a voice as well.
Let's assume this is one of the question in maybe a theory exam, and it says, given that V equals to U plus AT, explain. Tai, what would you write?
Sir, I'll leave it to you question mark.
You
Because
put you put question
I'll
mark.
put question, I'll put
You're on,
question mark.
you're on your own, okay? Now, let's listen. Is there anybody that can explain how?
Yes, first equation of motion.
Is the first
No, we are.
agreed. Agreed is the
We
first
are.
equation of motion, but how?
P is the final velocity,
Mm.
which
Hmm.
equals to
Mm.
initial velocity plus
Mm.
acceleration times
Yeah,
time.
that's correct, but how? How is it equal?
Okay, since
Okay,
P,
now listen. From the definition of acceleration, what is acceleration? So acceleration equals to rate of change in velocity, okay? Is that clear? Then we can have final velocity minus initial velocity, that's the change. Then A equals to V minus U over T. Then when you cross multiply, you make V the subject of the formula. So V minus U equal to AT. Then V equals to U plus AT, equation 1. Is that clear?
Yes, sir.
You're going to get the note later. The next one that they could ask you is, they could say, given that, or that you should show it, you should prove it. Show that S equal to UT plus half AT square. If they ask you to show this, you're going to use the definition from average velocity. Average velocity, V average. Are you listening?
Yes, sir.
Average velocity, V average, equals to displacement over time. Okay? This is displacement. and this is time. Now, if you have this average, you find average of something, maybe v plus u over 2, that's the average. Then that is displacement over time, okay? Is that clear?
Yes, sir.
Then here, you can substitute, since you already know v, okay? What is v? V is u plus at, right?
I know the question.
V is u plus at, right?
Yes, sir.
So that means you replace v with u plus what? At.
Replace.
Then plus another u, okay?
Yeah.
You know this v is changing, okay? Can you hear me?
Yes, sir.
This v is, the v above is u plus at, okay? Is
Oh,
that
yes,
clear?
sir.
Now you have over 2 equal to s over t. So at this spot, you can make s the subject. So you multiply both side by t, multiply this side by t. Then on the right side, t cancel t. Then you have s equal to, if you use t to open the bracket, you have or right now even here we have 2u, okay, plus 80 because there's no bracket here. Is that clear?
Yes, sir.
Let me remove that green circle so that you can know there is no bracket. I just use it to refer to the, hold on. I only use it to refer to the v above, okay? Is that clear?
Yes, sir.
Excuse me. So it doesn't exist there. It is still u plus 80. So we have 2u there plus 80, okay? All over 2 multiplied by t. Um, then finally, you can say s equals to 2ut over 2 plus 80 square over 2. So if 2 cancel 2 here, we have s equals to ut plus half of 80 square, okay? That is 80 square over 2. Is that clear?
Yes, sir.
Okay. The third one, which is the third equation of motion, they can ask you to prove it. What's the third equation of motion?
And
U square equals to U
this
square
square equals
plus
to u
two
square plus
AS.
2s. Yeah, yes. Wait a second.
Prove that v square equal to u square plus 2as, right? So,
Sorry.
so how do you think we can do this?
Yes.
You do follow this.
Yeah.
Sir, I think you
It's still
that
this
was
is the same method that we use for the second one we're going to use. Okay?
so that means v equals to s displacement over time.
Yeah, hold on. That is it. So V average, okay,
Yes,
equal to,
displacement over time.
yeah, displacement over time. Now this V average is V plus U over 2
Over T, over T, yes.
displacement over time. But from acceleration equals to V minus U over T, then T equals to V minus U over A. Okay?
Yes.
So you substitute for T. You bring this T into this place. So that means V plus U over 2 equal to S divided by T, right?
Yes, sir.
So V plus U over 2 equal to S divided by V minus U over A. So here V plus U over 2 equal to S times A over V minus U. Okay?
Sir.
Good. So let me try to bring it up. If we multiply through that place at the top, we have V plus U over 2 equal to AS over V minus U. Then we cross multiply, okay?
Yes, sir.
So we have V plus
Two
U
A's.
into V minus U equal to 2AS. Then, if we expand this, we have V squared minus U squared equal to 2AS. Then we have V squared equals to U squared plus 2AS.
Two A's.
That is the third equation, okay?
Yes, sir.
So, you know S, you know U, and you know what A stands for. So that is how to prove. Now, what is the first law of motion? Newton's law of motion.
Eh?
First, Newton's law of motion.
Say that a body move in a
Newton law of motion, huh?
say that a body
Yes.
will move in a straight line without in being move in a continuous motion in a straight line, uniform motion, without being something by external forces.
Okay. What the law actually
Yes,
states
sir.
is that
Every option remain in a state unless the info is being applied. Blah blah blah.
a body remains in a state of rest, okay,
Mm.
or of uniform motion,
In a straight line.
unless you don't
Being
need to
acted
mention
upon.
straight line. Anything uniform is linear, okay?
Yes, sir.
So
There's no-
uniform motion, unless it is acted upon
There's nothing.
External person.
by an external
Sitting down in the book.
force. So that means if it's at rest, it will continually be at rest forever unless a force acts on it. And if it's in linear motion or uniform motion, it will continue to be in that motion unless something stops the motion. Maybe it run out of fuel or hit an object. What about Newton's second law of motion? It says that the rate of change in the momentum of a body of a body is proportional, is proportional to the applied force.
Good.
to the applied force. And the change takes place in the direction of the force. So if they ask you to show that F equal to ma, this is the law you are going to state, okay? Let's say you have a question that says show that or prove that F equal to ma, where F is the force, m is mass, and a is acceleration. Can you hear me?
Yes, sir.
Okay. So show that F equals to ma, we say force is directly proportional to the rate of change in momentum. What is the formula for momentum? mv. Now, we have F equal to, or just let's say proportional. Okay, if we remove the proportional, we put a constant, then final momentum minus initial momentum over t. Then F equal to the constant, then into, that's m into v minus u over t, where v minus u over t is acceleration, then F equals to km acceleration. So it is assumed that constant equal 1, then F equal to ma. Is that clear?
Yes, sir.
Okay. So what about the Newton's third law of motion?
In every reaction,
There's an
there's
backward
an
and
equal
forward,
and in every
backward and
distance,
forward equal
there's an
reaction.
equal
If you
and
monitor,
opposite
if you go opposite
reaction.
anyone,
For
equal.
every action, there's
Mm.
an equal and
There's
opposite
a forward and backward
reaction.
and
So
opposite every
stop saying
reaction.
rubbish abeg. Mhm.
It's the same thing.
Yes,
Forward and
no,
backward is not equal.
no,
Front and side,
okay,
everything
so
is
Bob.
not equal. For every action, there is an equal and opposite reaction. Either opposite, negative, objective.
Don't try to do it in their life.
Alright.
Can you
That
give
gives now.
can you give examples that illustrates this third law?
You have
Third
to.
law, equal and opposite.
Okay, yes. So when you
I
the person will react, the action.
That's not opposite and equal.
Oh gosh, so that's what you guys have in class.
Then it's incorrect.
Mm. Now you know, studies there. I know you're not passing English.
Mm. Let's look at this. Let's see.
Okay, when you jump, the leg.
Mercy, read this.
A person in a rainboat. Is it rainboat?
That's
Hey,
it.
I'm not seeing.
yes, it's one boot.
Okay, do this thing. Person in a rowboat.
No good.
Roll now, roll boat. Start an action force on the water, and the water is at a reaction force on the rowboat, propelling it forward.
So that is one example, okay?
Yes, sir.
So if they ask you to give example in exam, don't mention that thing you just said now, okay?
Don't they give us class now?
In class, sorry. WAEC will not take that from you, okay?
Yes, sir.
Mm. WAEC will take something scientific from you. Is that clear?
Yes, sir.
So let's look at this.
Yes, sir. Just keep it.
Moses, read this.
Firing of a bullet. When a bullet is shot from a gun, the gun puts a force on the bullet that propels it forward.
So that is another example. Okay. Is that clear?
Yes,
Yes,
sir.
Then let's see. Taye, read this.
a book laying on a table. The weight of the book is acting in the downward direction on the table.
So the book, the weight is acting in downward while the book is supporting it upward. Is that clear?
Yeah,
Yes, sir.
And one more
Please,
example.
Moses,
During swimming,
a
as the
swimmer
water moves backward, you push the water back, the swimmer moves ahead. Okay. Is that clear?
yes, yes, sir.
Okay.
Can
Let's see.
I told you.
like that. That's finished for you with that. So,
So the next question will be for Moses. Okay, let me see. Moses, check this. Read it. Let me hear.
In collision between two objects, kinetic energy is conserved only if A. One of the objects was initially at rest. B. Potential energy is converted to work. C. The collision is inelastic. D. The collision is elastic.
So, which option do you go for?
you know, this negotiations.
Take.
This kids, this one is kid.
Yes, which option do you go for?
D.
No, no,
D. When the collision is
no.
elastic. That's correct. Okay. So, further explanation to that, elastic
Sir?
elastic collision occur when both the momentum and kinetic energy are conserved, while inelastic collision, on the other hand, happen when only the momentum is conserved but not the kinetic energy. So, some of the kinetic energy of the system is then transformed into other forms of energy. Is that clear?
Yes, sir.
Okay, the next question will be for Messi.
D.
Jesus, right to
So, Messi, read this.
The quantity of the quantity of motion of the bodies is what?
Quantity.
Quantity of motion of the body.
I don't understand quantity.
Yeah, field is quantity, momentum now.
So, what's your answer?
Momentum, momentum, momentum.
momentum. That's correct. And what is the formula for momentum?
Huh?
What is the formula for
Okay.
finding the momentum? Yeah, that is mass times velocity. Okay, is that clear? Can you hear me? Let me know if you can hear me. Okay, let's see. Can you hear me now?
Yes.
Yes, sir.
Okay, I think it's the network that is going on and off. So let me see the next question for Tai.
Okay.
Because
So Tai, read the next question.
The volume of a fixed mass of a gas vary, vary, Jesus, varies the pressure on its on the probe temperature constant is by the way the boys normal shey boys boys
Jesus. Oh boy.
What did you say?
boys law sir.
Boy's law. That's correct.
I said boys law.
Boy's law. Yeah, that's correct.
Yeah.
So the volume of a
So
fixed mass of gas or a given mass of gas varies inversely as the pressure, provided the
what are
temperature
you
is constant. Okay, the next question.
doing? You can hear me. Sorry to
The next question will be for Mercy or for Moses, right? Wait, so number.
check my watch.
Anime form on the
So
screen is
Moses,
always
is it for
maybe from
Moses
my
or
screen is
for who?
always Messi.
Moses.
Messi.
No answer any question since. Side Moses.
It's for Moses.
Email from
Yes, sir. Is it virtual?
is the answer are correct, but
The specific answer they need. It's
yeah,
not magnified.
it
Not
cannot be
inverted.
upright.
How now? How can
No,
you
no,
say?
Virtual.
Image form on the
it's
screen.
not
Focus on
actually
the
inverted.
retina then.
It's virtual.
Should pick virtual first.
You
Since
pick
focus
you
on
why
the
not answer a big virtual?
sir, Moses said virtual.
It's inverted. Okay,
Inverted.
That's a no.
inverted.
Hey, so what's the bed now?
So this is better.
Yes, ma'am. You can't invite me like that.
Um, okay, for Mercy.
This is better. 22.
uh,
So, it's when I thought you could have sent the video because I'm not writing.
No problem. I've always been sending the link to the video. You can ask from the person to get all of the links.
Hey, go
Send it
around.
to
Just
me.
go
No, it's not
Uh,
around.
I'm sending them.
the person can,
Sir,
hello, tell mommy or whoever. I will tell him to forward everything to mom to send to you. Or you have his number now. You can just send to you, okay?
Give send the message. Yes,
Or he
sir.
won't send it.
sir,
Don't you trust
He
your
will send
phone?
you the link now if you ask him. I will message mom to mention about it that you guys have not been getting the lecture video so that she can inform the person too. So number 5. So Mercy, check this.
How would the capacitance of a parallel plate capacitor be affected if the distance of separation of its plates is decreased? It will dash one increase in value,
Two. Seven.
decrease.
So
Yes.
yeah, we're going to continue right now, okay? Let's see.
90
Eh,
that is 2 minus. Just two minus.
but that's 42.
Can you hear me now?
Yes, sir.
Okay. So we said the capacitance of the parallel plate capacitor will increase when the distance of its separation of its plate is decreased. Is that clear?
Yes, sir.
Okay. Now the next one.
Who is that?
Who is answering the next question?
Taye.
Okay, so Taye answer this.
Which of the following
Machines does not apply
machine
the lever
does
principle.
not apply the lever principle? Ah, okay. Sir, single pulley.
Single pulley.
Sir, is this?
Yeah, single pulley, that's correct, okay? The principle, please listen, the principle of the lever, it has been found by experiment that two equal forces acting in opposite direction, like clockwise and counterclockwise, and applied to a uniform level at equal distance from the fulcrum, counteract each other and establish a state of equilibrium or balance in the lever. And that is the lever principle, okay?
Yes, sir.
So forces acting in opposite direction, which can maintain a balance. And it's seen in the 3 objects, the 3 options. But this one does not apply the lever principle, okay?
Yes.
Is that clear?
Yes, sir.
Okay. So
How
let's see. For Moses, right?
Yes, sir.
Okay. So Moses, check this.
The average distance moved by a molecule between positions is called average. What's this question? So, every distance. Mean distance. CD. CD.
It is the main free part, okay? So the main free part is the average distance traveled by a moving particle such as an atom, a molecule, or a photon between successive crests. Okay? Is that clear?
So this is the answer.
D is the correct answer.
A. Yes, sir. He has come to this project. Like he has a.
So the next one,
So you want to tell
He has two daughters. Two.
for Mercy.
Yes, sir.
He's celebrating 60 years.
Mercy, check this.
Which of the following waves require a material medium for propagation? Mechanical wave require a material medium for propagation. So, the next will be
Those roles. Yes, no.
yes.
Yes, no.
Yes.
So which one?
The is
Chemical distillation. So I think light will require the vacuum. So I think the light waves.
That's great. What we need to take note of is that all electromagnetic waves require no material medium to travel.
Yes.
But mechanical waves need material medium for its transmission. And we can create sound mechanically. The light, radio, and X-ray, they are all electromagnetic waves, okay?
Yes, sir.
No material medium. But this one, which is sound, require a material medium. Is that clear?
Yes, sir.
So sound wave is an example of a mechanical wave. And it's also a longitudinal wave, okay? Is that clear? So the next one is for
You
Taye.
see, that one plus two.
So Taye, the depolarizing agent in a Leclanche cell is dash. Just take note of this because you did not practice anything in a laboratory to determine this, okay? Is that clear?
And that's what I did.
So the depolarizing agent in a Leclanche cell is manganese 4 oxide. What is the molecular formula for manganese 4 oxide?
NNO2. NNO
3.
4 is 2 now. MnO2.
MnO2. Okay, the next one is for Moses. The material used to slow down the neutrons in a nuclear reactor is dash. Well, this is more like something you need to learn theoretically because you are not going to practice it. So it's graphite, okay?
Yes, sir.
So the next one for Mercy. Which of the following statements explain why hot soapy water is more effective in cleaning oil-stained dishes?
The oil on the dish repair the soap and will degrade the surface tension, soap and tension, and the impact of waters, hot water on the surface tension. But soap increase the surface tension of oil and soap. Soap water, soap
Which
and-
option? A, B, C, D.
So I think C.
The soap will decrease, soap and the heat will decrease the surface tension of oil, okay? Particularly the heat, okay? So when the surface tension is decreased, then it will be more effective. Okay, so that's what we're running off for today, okay? All right?
Yes, sir.
By the grace of God, we'll meet on Tuesday. But I will message Mom maybe right now that she should tell the person to give you guys the video. All of the videos, all of the links to the videos so that you can download them. Okay?
Yes, sir.
All right, so you have a nice time.
Thank you, sir.
Why you tell the earth?
Don't worry, I'm sending the images of the notes, all the pictures. Then I will also send the link to the video. Bye for now.
Thank you, sir.